हेलो स्टूडेंट्स, आज के इस सेशन में हम फ्लूइड मैकेनिक्स के ऊपर कुछ बड़े ही कॉन्सेप्चुअल से क्वेश्चन करेंगे। सेशन को लाइव रखा है जिससे कि आपको वीडियो रियल टाइम में तुरंत मिल जाए। आइए देखते हैं हमारा आज का ये पहला क्वेश्चन। क्वेश्चन सेज अ स्मॉल सॉलिड बॉल is released from rest deep inside a liquid tank. There is a liquid tank, and deep inside the tank, a small ball is released from rest. Its kinetic energy K naught is measured after it travels through a distance of 8 centimeter in the liquid. A ball is released deep inside a liquid. Now its kinetic energy is measured after it has traveled 8 centimeter inside the liquid. ये ग्राफ जो है के नॉट और लिक्विड की डेंसिटी के बीच का ग्राफ है। एक्सपेरिमेंट इज रिपीटेड विथ मेनी नॉन विस्कस लिक्विड। Pay attention to the keyword. The liquid is non-viscous. There is no viscosity force, and the experiment is repeated with many different liquids. On the y-axis, we have plotted the kinetic energy of the ball after it has traveled through a distance of 8 centimeter, and on x-axis, we have plotted the density of various liquids. Graph is as shown. Now you have to find two things from the given information. First is what is mass of the ball. That is one thing. The second thing is find the density of a liquid which is heavier than water, in which K naught will be equal to 4 joule. Take value of G to be 10 meter per second square. So this is the question I am getting out of the screen. You can take a screenshot and read the question once. Try to solve it on your own. Okay, here I am there to solve this particular problem. Deep inside the liquid, a ball is released. There is no viscosity, buoyancy is there, right? So there is no viscosity, but buoyancy is there. So there are only two forces acting on this ball, its weight and the buoyant force. Okay. Now the question says that we are plotting the kinetic energy of the ball after it has traveled a distance of 8 centimeter inside the liquid. K naught is kinetic energy after the ball has traveled 8 centimeter inside the liquid. And on this side, we have the density of the liquid. Now look at the two key points in the graph. Look at this particular point. When the density of liquid is 0, when the density of fluid is 0, the kinetic energy acquired by the ball is 4 joule. This straight away gives you the mass of the ball. If there is no density of liquid, which actually means there is no liquid as such, there is no fluid as such, right? So there is no fluid, no liquid. So the only force acting on the ball is mg. So if it has fallen through some distance h, then what will be its kinetic energy? mgh, isn't it? If there is no fluid, density of liquid is 0, means practically there is no liquid. So the ball has fallen through some distance h. It has lost potential energy mgh, which has got converted into its kinetic energy. So after traveling 8 centimeter, when h is 8 centimeter, the kinetic energy of the ball is 4 joule. So this is 4 joule when h is 8 centimeter. So from here straight away we get the value of mass of the ball. So mass of the ball is 4 joule divided by g, that is 10, divided by h, which is 8 centimeter. Converted into meter, it will be 8 upon 100. So this is simply 40 by 8, 5 kg. Am I right? Yes. 400 by 80, 40 by 8, that is 5 kg. So mass of the ball is 5 kg. Straightforward. Students, ball has fallen through 8 centimeter. This 8 by 100 is nothing but distance traveled by the ball in meter. So mgh is 4 joule. Therefore, m is 4 divided by gh. So 5 kg is the mass of the ball. It was so simple. अभी भी आप अगर क्वेश्चन के दूसरे पार्ट को ट्राई करना चाहते हैं तो रुक जाइए, वीडियो को पॉज कर दीजिए, ट्राई कीजिए। क्वेश्चन का दूसरा पार्ट कहता है फाइंड द डेंसिटी ऑफ ए लिक्विड व्हिच इज हेवियर देन वाटर। दैट मींस density of that particular liquid should be greater than 1, in which K naught will be equal to 4 joule. अब इस ग्राफ में ऐसा दिख रहा है हमें कि अगर पानी की डेंसिटी 1 है तो 1 से हायर डेंसिटी के लिए तो नेचुरली काइनेटिक एनर्जी काफी कम है। ये ग्राफ ऐसा स्ट्रेट लाइन क्यों दिख रहा है? जैसे जैसे लिक्विड की डेंसिटी बढ़ती जाएगी, ये buoyancy फोर्स बढ़ता चला जाएगा। So, mg minus buoyancy will be the net force. Therefore, the acceleration of this ball will go on decreasing. Acceleration will go on decreasing as the buoyancy force increases, and buoyancy force will increase with the rising density of the liquid. Liquid ज़्यादा घना लोगे तो ज़्यादा बड़ा buoyancy force होगा, and therefore acceleration of the ball will be smaller, and therefore it will get smaller speed or smaller kinetic energy after traveling through 8 centimeter distance. So that is why this graph has been shown falling like this. Now, when the density of the liquid is 1.5, the kinetic energy attained by the ball is 0. What does it mean? It simply means that when the density of the ball is 1.5, density of the liquid is 1.5, the ball is not accelerated at all, which simply means that density of the ball and density of the liquid are same. Look at this situation. A ball has volume V. Let us say its density is D. The volume into density is mass into G. This is weight of the ball. अगर लिक्विड की डेंसिटी रो एल है, then the buoyancy force acting on the ball is V rho L into G, right? If rho L is same as D, if density of liquid and density of ball are same, then obviously there is no net force. So there will be no acceleration. You can just theoretically you can take it like this, that density of ball is just marginally greater than density of liquid. Therefore, there is almost a zero force, 0.00000001 Newton, acting in downward direction, which causes the ball to move through a distance of 8 centimeter. But how much kinetic energy it will gain? Almost no kinetic energy, because there is no acceleration. So this graph shows that when density of liquid is 1.5, ball is not able to gain any kinetic energy, which simply means that density of the ball is 1.5, right? Density of the ball is 1.5. Now again read the question. Find density of a liquid which is heavier than water, in which K naught will be equal to 4 joule. Now this can happen in only one way. When this buoyancy force is double the value of mg. Try to understand. When there is no buoyancy, acceleration is g, it travels 8 centimeter, its kinetic energy becomes 4 joule. Now the density of liquid must be greater than 1, as the question says. Take. So this ball is again released. Again it has to travel 8 centimeter and acquire the kinetic energy of 8 joule. How is that possible? It is possible in only one manner, when the ball has an acceleration equal to g. When it will have an acceleration g, after traveling through 8 centimeter, its kinetic energy will become 4 joule. पर buoyancy force के रहते हुए इसका acceleration downward g नहीं हो सकता. तो अब एक ही तरीका है कि अगर ये mg x है, तो buoyancy force 2x होना चाहिए. In that case, the ball will have an upward acceleration of g, and when it travels through 8 centimeter, again its speed will become, again its kinetic energy will become 4 joule. So it's very simple. The upward acceleration of ball should be g, which means upward buoyancy force should be 2 mg. This can happen only when density of liquid is twice the density of the ball. We have already concluded that density of ball is 1.5. So the density of liquid is 1.5 times 2, that is 3. So once you put the ball in a liquid that is denser than the density of the ball, which is denser than the ball, then what will happen? This graph will again start climbing up like this. Because अगर आप बॉल की डेंसिटी 1.5 से ज्यादा डेंसिटी वाले लिक्विड में इसको रखोगे, तो इस पे एक नेट अपवर्ड फोर्स आएगा, ये ऊपर की तरफ एक्सेलरेट होगा. 8 सेंटीमीटर चलने पे इसकी काइनेटिक एनर्जी कुछ तो होगी. अगर एग्जैक्टली इस लिक्विड की डेंसिटी बॉल से डबल हो गई तो 8 सेंटीमीटर चलने पे 4 जूल हो जाएगी. आई होप ऑल ऑफ यू हैव अंडरस्टूड दिस. लेट अस हैव अ लुक एट द अदर क्वेश्चन. A water clock consists of a vessel which has a small orifice O. ये वो घड़ी है ना, राइट? पानी वाली घड़ी, जैसे सैंड क्लॉक आपने सुना है, ये पानी से बना हुआ घड़ी है, ऐसा क्वेश्चन कह रहा है. आई थिंक दिस इज नॉट प्रॉपरली विजिबल. लेट मी टेल यू, ये पानी भरा हुआ है इसके अंदर, इस पोर्शन में, ठीक है. हाँ, तो क्वेश्चन ये कह रहा है कि वाटर क्लॉक हैज ए स्मॉल ऑरिफिस हियर. इसमें यहाँ पे एक छोटा सा छेद है, पानी ऊपर वाले कंटेनर से नीचे वाले कंटेनर में गिर सकता है. द शेप ऑफ द अपर और लोअर कंटेनर इज सच दैट हाइट ऑफ वाटर इन द अपर कंटेनर चेंजेस एट ए यूनिफॉर्म रेट. जब मैं इसको होल को अनप्लग कर देता हूं, खोल देता हूं, ऊपर से पानी नीचे गिरता है, और मजेदार बात यह है कि द हाइट ऑफ वाटर इन दिस कंटेनर डिक्रीजेस एट ए कांस्टेंट रेट. The height of water, this height of water decreases at a constant rate. ऐसा होने के लिए ये जो कंटेनर है इसका शेप क्या होना चाहिए, बेसिकली ये आपसे पूछा गया है. क्वेश्चन में एक आ जा रहा है कि अगर इसको ओरिजिन, इसको एक्स एक्सिस और इसको वाई एक्सिस मान ले, तो इस कंटेनर का जो इस डायग्राम में वर्टिकल क्रॉस सेक्शन होगा, ये जो क्रॉस सेक्शन है, इस कर्व का इक्वेशन क्या होगा, ऐसा क्वेश्चन में पूछा जा रहा है. आप एक बार इसको ठीक से पढ़ लीजिए. अगर हम इसे खोलते हैं और यहाँ पानी पानी की हाइट कांस्टेंट रेट से घटती है, पानी यहाँ से गिर के यहाँ जा रहा है, यहाँ जा रहा है, इस कंटेनर में, लोअर कंटेनर में, ये हाइट कांस्टेंट रेट से घटे, इसके लिए ये जो प्रोफाइल है इस कंटेनर का शेप क्या होना चाहिए. तो हमें बेसिकली 2 डायमेंशनल कर्व का इक्वेशन लिखना है. वो कर्व जिसको हम इस सिमेट्री एक्सिस के अबाउट अगर घुमा दें तो ये कंटेनर बन जाएगा, राइट? जैसे एक पैराबोला को आप सिमेट्री एक्सिस के अबाउट घुमा दो तो एक 3 डायमेंशनल सरफेस बन गया जिसको पैराबोलॉइड कहते हैं. उसी तरह मान लो, 1 मिनट के लिए, मुझे नहीं पता, अभी देखेंगे, 1 मिनट के लिए माने कि ये पैराबोला है, उसको स्पिन कर दो तो ये जो कंटेनर दिख रहा है ये पैराबोलॉइड है. तो क्या ये पैराबोलॉइड है? क्या y इज इक्वल टू के एक्स स्क्वायर इसके क्रॉस सेक्शन का इक्वेशन है, या कोई ऐसा इक्वेशन है, या ऐसा इक्वेशन है, ये आपको तय करके बताना है. यहाँ इन तीनों ही ऑप्शंस में जो k लिखा हुआ है, इट इज अ कांस्टेंट नंबर, k इज सम कांस्टेंट. बच्चों, इस क्वेश्चन को आप ट्राई करिए, स्क्रीनशॉट ले लीजिए, जरूर ट्राई कीजिए. यहाँ मैं इसको आपके लिए करने की कोशिश करता हूँ. बेसिकली क्वेश्चन ज्यादा कठिन है नहीं जितना दिख रहा है. बस ऐसा है कि थोड़ा सा लगता है कि हमने ऐसा नहीं देखा पहले, ये कैसे हम बता पाएंगे. इसके अलावा क्वेश्चन में ज्यादा डिफिकल्टी है नहीं अगर आप ट्राई करने पे आ जाए तो. देखिए, इस कंटेनर में मान लेते हैं किसी इंस्टेंट पे पानी की जो हाइट है वो y है. आप सभी लोग ये जानते हैं कि जो इस होल से पानी निकलेगा, इसका स्पीड ऑफ इफ्लक्स, इट इज अंडर रूट 2 g/. Question says this is a small orifice, this is a small hole. The cross section of the hole is very small compared to cross section of the container. In all such cases, the water will come out at a rate of under root 2 g/. Naturally, जैसे जैसे इसमें से पानी कम होता जाएगा, y कम होता जाएगा, and the speed of efflux will also go on decreasing. Let us assume that cross sectional area of this hole is A. So what is volume flow rate of water? 1 सेकंड में यहां से पानी का कितना वॉल्यूम बाहर आ रहा है? The answer is V into A, root 2 g/, into A. This is volume flow rate, right? This is the volume of water escaping out of this hole per unit time. If Q represents volume, then this is dQ by dt. This is what I am saying. This is volume flow rate. Okay. Now, consider a time interval dt. Just consider a time interval dt. In that dt second, dt is a very small, infinitesimally small time interval. In that dt second, the volume of water that will come out will be this into dt. dq will be equal to this into dt. Now, in dt second interval, the volume of water that has come out of the hole is this much. Because of that, the water level falls by dy, right? वाटर की सरफेस यहां से यहां आ गई, पानी थोड़ा निकल गया dt सेकंड में इतना, जिससे जो अपर सरफेस है ये थोड़ा सा ऐसे नीचे आ गया, right? How can we write dy? Look at this. Let us say here the x coordinate of this particular point is x. This is x. This container is symmetrical. This distance is coordinate wise. This point has a coordinate of minus x. This length is x. This length is x. So the area of cross section of the container over here is pi x square. It is a circular cross section of radius x. So pi x square is the circular cross section, and this thickness I am saying water falls down by some amount dy. So the volume of water that has come out can be written as pi x square into dy. Pi x square into dy. पानी कितना बाहर निकला dt सेकंड में, इसको दो तरीके से लिखने की कोशिश कर रहा हूं. एक, स्पीड ऑफ इफ्लक्स इनटू क्रॉस सेक्शनल एरिया, दिस इज द वॉल्यूम फ्लो रेट, दिस इनटू dt सेकंड में इतना वॉल्यूम पानी का बाहर है. दूसरा, dt सेकंड में अगर ये लेवल dy नीचे आ गया तो वहां से कितना वॉल्यूम साफ हो गया, पाई एक्स स्क्वायर इनटू dy, isn't it? So these two should be equal. पर एक छोटा सा करेक्शन हमें कर लेना चाहिए, यहाँ पे एक माइनस लगा देना चाहिए, क्योंकि जो dy है चेंज इन y वो निगेटिव है, y is decreasing. So I cannot equate a positive number to a negative number. इसका mod लिखना है, dy, y is decreasing, so dy is inherently negative. I must put a minus sign to take its modulus. So now this equation becomes like this. Okay, so look at this now. Pi x square minus dy by dt. Please have a look at this. I am writing it in this way. Pi x square minus dy by dt is equal to root 2 gya. What is this term? Minus dy by dt. Rate at which y is decreasing. Question says this should be constant. According to the question, this rate of fall of height of water should be constant. It is a constant, any constant. Let me write it as c. So pi into c into x square is 2gy into a. Isn't it? If I just square it, this is like this. So y is equal to pi square c square 2g a square into x raised to the power 4. Now this whole thing inside the bracket is a constant. So y is some constant into x raised to the power 4. This is the equation you are looking for. What is x here? X is x coordinate of this point. What is y here? Y is nothing but y coordinate of this point. So x and y are coordinates of a point lying on this curve. So naturally this is the equation of the curve. So the container can be constructed by imagining a curve like this, and then you spin the curve about this y-axis, you get the three-dimensional container. So this is the second question. There is another question which I was thinking of considering, but I will not consider it today. I'll consider it in next or maybe next to next session. So this much is enough in today's video. See you all in next video. Goodbye.